Graphing quadratic functions. How does graphing a quadratic function compare with graphing a linear function? Well, remember we can make that kind of comparison about y equals mx plus b, which is for our linear function, and our quadratic, we have y equals ax squared plus or minus bx plus or minus c. I should say plus or minus b then. Well, we know that that slope can tell us the angle of the line. Uphill, downhill, things like that. The same is true for the letter A. The letter A, if it's positive, it opens up. If it's negative, it opens down. Again, the number, the constant that sits out here that's not connected with any variable always tells us the y-intercept. The same thing is true here with the C. The C will also tell us the y-intercept. So there is some similarities. So let's use those similarities to our advantage when we're graphing. So we've got a plan here that we can adapt. We can, by step one, put it in standard form. If we can put the quadratic in standard form, and again, that's where we have the x squared term first, then the x term, and then the constant, we can see what's going on and we can look at the characteristics and know what to expect. We then look at step two, which is find the axis of symmetry. We're going to do that. We're going to look and find that by taking the opposite of b, dividing it by 2a, finding that axis of symmetry, and that's also going to give us the x coordinate of the vertex. Step three, we're going to use that x coordinate of the vertex to find the total vertex. Plug it in, find the y. Once we find the y, we've got the vertex then, an ordered pair. We can put it on the graph. We have now on the graph the axis of symmetry and the vertex, and we can plot that. We can then go find another point by choosing a number such as 1 or 2 and plugging it into the equation to find another number to get us a point. We would mirror that to the opposite side of the axis of symmetry, put it on the graph, and the last thing we would do is to draw our graph. So hopefully I'll be able to show you these steps in the next few examples. So here we have y equals x squared. Now looking at this, we know that it's positive. The a is positive, so it's going to be opening up. So let us find what the axis of symmetry is. So and we notice there's nothing out here as well, so more than likely it's going to cross at 0 because there is no c out here. So a is 1 and b equals 0. If we remember that to find the axis of symmetry, it is the opposite of b divided by 2a. This would be 0 divided by 2, which would end up being 0. So that means our axis of symmetry is x equals 0. So let's get a line here and draw it here as our axis of symmetry. So we're going to put that right on the y-axis. Now, we're going to use this 0 as part of our vertex, and then take this y equals x squared and plug 0 into that to find out what y would be. Well, when 0 times 0 is 0, that would be our vertex. Now we need another point, so let's try the point 1. And plugging in 1, we get y equals 1 squared. Well, 1 times 1 is 1, so we know that we're at 1, 1. We're going to mirror this point to the other side based on the axis of symmetry. If it's 1 away here, it's going to be 1 away over here. And then at that point, we can just draw our parabola to show that it continues, and making sure that we're drawing a U shape. And that's the basics of what we're doing. Let's just kick it up a little time each time so that we can kind of see as we go through it how it changes as we add things to it. So this will be kind of our norm reference base, y equals x squared. Let's continue with y equals negative x squared plus 4. Well, that negative tells us that this is going to go down. This is not going to be floating up, it's going to be floating down. And this 4 tells us that our y-intercept will be at 4. Because a is negative 1, there is no b, so our b is at 0. Again, when we're looking for the axis of symmetry, the opposite of b, well, the opposite of 0 is still 0. And when this works out, this is still going to be 0. So again, our axis of symmetry is going to sit at x equals 0. So let's put that axis of symmetry on our graph. Now what we're going to do is use that point of 0 to find our vertex. So we're going to plug into y equals negative x squared plus 4. So the opposite of 0 squared plus 4, well, the opposite of 0 is just still 0, and 0 plus 4 is 4. So we know that 0, 4 is going to be our vertex. We do need to get another point, and let's try the number 1. Remember, it's good to choose numbers that are easy to do. So negative 1 squared plus 4. Remember, this is the opposite of 1 squared. Well, we know that 1 times 1 is 1, but this is still negative 1 because it's the opposite of positive 1, plus 4, which would give us 3. And again, we would see that we're going in the right direction. If you didn't remember this, if you thought the opposite of 1 squared, thought that this whole thing turned out to be positive, you would have gotten a 5 and had gone up. But you knew looking here that this was negative, so you knew it had to go down. So again, it's 1 away from the axis of symmetry, 1 away from the axis of symmetry, and we're going to draw our parabola going down. So it's really good to know your characteristics before you start, just in case you mess up a little bit with your integers. Okay, let's take a look at this one. Again, it's going to open up. It's going to cross at -3. In fact, I could put a dot right away at -3, couldn't I? Because I know my graph's going to go through there somehow, some way. It's going to cross through there, somehow going up. So more than likely, our vertex is either in the 3rd quadrant or the 4th quadrant. So A equals 1, B equals -2, and we can put C equals -3 up there, even though we're not using it quite yet. Let's find that axis of symmetry, which is the opposite of B, divided by 2A. So since B is -2, the opposite of B is 2, and we're going to divide that by 2 times 1. Well, 2 divided by 2 equals 1, so knowing that our axis of symmetry is at 1, let us get a line and draw our axis of symmetry at 1. Now we want to find our vertex. So at this point right now, we know that the x is our x-coordinate of the vertex. Let's plug that into our equation of y equals x squared minus 2x minus 3. So we're going to have 1 squared minus 2 times 1 minus 3. And all we're going to do is order of operations. And we're going to work it out until we get it solved all the way down, and we get -4. So we get 1, -4. So 1 going down to -4. Here's our vertex. And remember, we know what the y-intercept is, so we don't have to plug in to find it. There's that other number we need, and since that's 1 away, we know that this will be 1 away on this side, and we're able to draw our parabola. So if you look at what's going on, you're able to do less work before you start working, if you can make some evaluation and take a look at the characteristics of it. Let's take a look at this one, our last one, y equals 3x squared minus 6x plus 1. And again, this is going to be going up, but this 3 tells us 3 times as high. So if this is going to go up 3 times as high, this should be very narrow. So we should keep that in mind. Okay, so it's going to go up, it's going to be narrow, and our y-intercept is at +1. So let's put that on there so we know what's happening. A is 3, B equals -6, and C equals 1. So again, we're going to take the opposite of B and divide it by 2A. Well, the opposite of B happens to be 6. 2 times 3 is 6, and 6 divided by 6 is 1. So that means our axis of symmetry is at 1. So let us grab that and put that on our coordinate plane and get that square on there. Okay, and then what we're going to do is we are going to now use that 1 and we're going to find our vertex. So we're going to plug 1 into y equals 3x squared minus 6x plus 1. So y equals 3 times 1 squared minus 6 times 1 plus 1. And again, just order of operations. Ends up being 3 minus 6 plus 1. And continuing on with order of operations until you get down to your final answer. And here we get 1, -2. So 1, -2. There's our vertex, and there's that -1. We said we know it's going to cross there, and since that's 1 away from the axis of symmetry, it's going to be 1 away. And we can see how this got narrower, 3 times narrower, didn't it? So as it comes up, let me see if I can get a better arrow going here. So you want to draw that parabola and let it climb. Same thing here on the other side, and let it climb. It's going to be rising very quickly. A big difference from the other parabolas, which were just standard x squared. See how much wider they were? You know, this last one, because it was that 3x squared, it got narrower. So the larger that number, the narrower it's going to get. And again, the flatter that number, the flatter it'll become when it gets to be like 1/4, 1/2. It'll get flat and flat and flat until it totally disappears to 0. Because if it was 0x squared, this would be gone, and all we would be left with is this part, -6x plus 1, which we know is a line. So once this is gone, that's what will happen. So we can kind of see how those characteristics play out. And that should help you with your graphing of quadratic functions.